Now let us see problem in Conicoid. It is a previous examination question. I mean, it is important question for you. Prove that the equations of two tangent planes. Prove that the equations of two tangent planes to the ellipsoid x square by a square plus y square by b square plus z square by c square, x square by a square plus y square by b square plus z square by c square is equal to 1, which passes through the line u is equal to, that line notation they are giving you, it is Lx plus My plus Nz minus p equal to 0, comma u dash is equal to L dash x plus M dash y plus N dash z minus p dash is equal to 0 is, that means that answer is u square into a square L dash square plus, sorry, a square L dash square plus b square a square L dash square plus b square M dash square plus c square N dash square minus p dash square minus 2u dash 2 into u dash into a square L dash plus b square into M dash plus c square into N dash minus p dash is equal to, otherwise plus u dash square into a square M square plus b square M square plus c square M square minus p square is equal to 0. Here two corrections do properly. One correction in your material, this is p dash, it is not clear by the notes, and here they take it wrong in the statement. They write a square L dash square, b square L dash square again they written, but it is what, b square L dash square plus c square L dash square again written, it is c square L dash square. These two terms make correctly in your material while you are writing notes, right? This is M dash square, this is N dash square, but in the notes again it is L dash square, the written one, it is wrong. Make that one correct, right? This is about your question. I think you understood that question. Prove that the equation of two tangent planes to this ellipsoid which passes through this line means p is equal to 0, this equal to 0, I mean u is equal to 0 and u dash is equal to 0. These are the two lines. Here also take 0 in the material not available. This is equal to 0. I mean u equal to 0 and u dash equal to 0 is unsymmetric from equation of the line. Now, what is the line that passes through intersection of these two planes or through this line? It is p plus lambda q condition. P means what here? U plus lambda u dash equal to 0. In the planes I given this condition. The equation of a plane which can passes through the intersection of two planes p equal to 0, comma q equal to 0 is what? P plus lambda q equal to 0. Here instead of p we have notation u, instead of q we have notation u dash. This is the line which can passes through This is the plane which can passes through this line. Right? And this plane should be what now? Tangent plane to this conicoid. I mean, first I want to form this one. Here lambda is unknown. To find lambda value, what they given now? They given that this is tangent plane to this condition. Whenever this is tangent plane to this condition, if Lx plus My plus Nz equal to P is tangent plane to this conicoid, according to theorem number 2, what do you say, ma'am? P is equal to root L square by A plus L square by B plus N square by C. Otherwise here P is equal to root A square L square plus B square L square plus C square L square. Use that condition, ma'am. And then a little bit simplification do, ma'am. You get this relation. That completes your total question. First, form a line which can plane which can pass us through this line, ma'am. It's intersection of these two planes, ma'am. That is this. Here lambda is unknown. To find lambda, let us use your given condition. What is it, ma'am? This plane tangent plane to this one. Whenever this is tangent plane to this one, according to your theorem number 2, P is equal to root A square L square plus B square L square plus C square L square. With that, and eliminating lambda, you get your this result. That completes your total question, right? But in the beginning stages, I want to take given conicoid. Given conicoid is, what is that? X square by A square plus Y square by B square plus Z square by C square is equal to 1. Right? This is the decided. Next, let us form a plane which can passes through this line. Right? The equation of a plane passing through the line is what now? U is equal to Lx plus My plus Nz minus P equal to 0 and U dash equal to what now? N dash x plus M dash y plus N dash z minus P dash is equal to 0 is that plane equation is what now? U plus lambda U dash is equal to 0. Take it number 1. U plus lambda into U dash equal to 0, where lambda is parameter. Yes. Now we are going to find lambda. For that, I want to substitute this U result and U dash result here. This implies, I want to continue equation 1 also. What is U? Lx plus My plus Nz minus P plus lambda into what is U dash? N dash x plus M dash y plus N dash z minus P dash is equal to 0. Right? Now this one write in the proper plane form like Lx plus My plus Nz equal to P formation. For that, first of all, I want to write L coefficient, X coefficient. This is X coefficient, this is X coefficient. It is what? L plus lambda into N dash x. Next, Y coefficient. M plus lambda into M dash y. M plus lambda into M dash y. Plus Z coefficient is what? N plus lambda into N dash z. X, Y, Z coefficients over 1 x what? Minus P minus lambda P dash. I want to take on to other side. It is P plus lambda P dash. Let it be, this is some number 2 for our terminals. Okay. This is a plane can passes through this line. Right? But in the statement, what they are giving on? It is tangent plane to the conicoid. Whenever this is tangent plane to the conicoid, according to theorem number 2, what we have? P is equal to A square L square plus B square M square plus C square L square. Here instead of L M N, what we have? L lambda L dash, M is M lambda L dash, N is what now? N lambda L dash, and P is what here now? P plus lambda P dash. Just I am using that tangent condition or tangent condition. Given that above plane is tangent plane to the given conicoid or given ellipsoid. This conicoid means what? Ellipsoid. Given ellipsoid, you can write it as ellipsoid or conicoid, no problem. What is that? X square by a square plus y square by b square plus z square by c square is equal to 1. Given that this plane is tangent plane to this ellipsoid, no? So that is what we have. P plus lambda p dash is equal to, that means P is equal to square root of a square l square, a square l square, a square into l plus lambda l dash plus b square into m plus lambda l dash, b square into m plus lambda l dash plus c square into n plus lambda n dash. Any problem with this one? Just for your convenience I am writing the condition. Since P is equal to square root of a square l square plus b square m square plus c square m square. This condition we use it there. Right? To remove this root, no, I want to take square condition on both sides. I mean this implies P plus lambda p dash whole square is equal to a square into l plus lambda l dash plus b square into m plus lambda m dash plus c square into n plus lambda m dash. I want to continue this one. I want to proceed this one and write down lambda square coefficient separately, lambda coefficient separately, and free from lambda coefficient separately. Here a square, l square, l square means what? This is square, this is square, this is square. Here also this is square, this is square, this is square. Because a square, l square plus b square, m square plus c square, a square. I forgot that square. Right? In the next step, expand this one according to a plus b whole square condition. Right? And then write lambda square coefficient separately, lambda coefficient separately, and free from lambda coefficient separately. First of all, I want to write this side lambda square coefficient, right side. Right side lambda square coefficient separately. Lambda square into, this is b square term gives lambda square or not? A square l dash square, a square l dash square plus b square m dash square plus c square n dash square. A square l dash square plus b square m dash square plus c square n dash square. Next here also available. This I want to take on the other side. Expand this one according to a plus b whole square. Now take this is what lambda square term. It is what p dash square. Here you can write directly minus p dash square. Because after expanding, take this total terms to other side. This is lambda square coefficient plus lambda coefficient right down. In this a plus b whole square expansion, 2ab term gives what? Lambda coefficient. Now I am taking 2 common and lambda common. 2 common, lambda common, a b a square into l dash, a square into l dash. Here what? B square into m dash plus c square into l dash into lambda. Any problem is there? I mean, sorry, one more term. Left side term we have to take on to this side. That I forgot. Here also. 2ab term gives what? Lambda coefficient. 2 lambda outside. It is what? P dash. Minus. If you can take on to this side. Minus P dash. Go into lambda. Plus free from lambda term right now. What is that free from lambda term? A square l square plus b square l square plus c square l square minus b square. A square l square plus b square m square plus c square m square minus p square. Any problem with this? Is equal to 0 because this total, we are taking this total term to other side, but this total thing becomes 0. This This left side portion is 0. I want to write on right side. Any problem with this one? Let it be this is some relation number 3 for our convenience. Right? Now come on to equation number 1. Here u plus lambda u dash equal to 0. By this, is it possible to find lambda or not? Substitute that lambda here. That lambda here. No? You get your required result. Right? From 1 implies what is lambda? What is the condition of u plus lambda u dash equal to 0? This implies lambda is equal to what? Minus u by u dash. Lambda is equal to minus u by u dash. Substitute this in number 3. From 3 implies, direct I am writing from 3 implies. From 3 implies, yes, lambda replaced with this one. It is minus whole square becomes positive only. It is what? U by u dash whole square, otherwise u square by u dash square I am writing, into a square l dash square plus b square m dash square plus c square n dash square minus p dash square plus 2 into lambda value here I want to substitute. Lambda is what now? Minus. So that this space becomes minus due to this one. U by u dash into lambda value here I substituted one. Minus into plus becomes minus into this result one. A square l dash plus b square m dash plus c square n dash minus p dash plus this term right as is a square l square plus b square m square plus c square n square minus p square is equal to 0. Just we substituted lambda value. Right? In the next step, I want to remove this u dash square, denominator u dash square. For the multiply throughout expression with what? U dash. Multiplying throughout expression with u dash, what we get? Just write simplify result. U square into a square l dash square plus b square m dash square plus c square n dash square minus p dash square minus 2 into u dash, because we are multiplying u dash square. One u dash gets cancelled. 2 into u dash into a square l dash plus b square m dash plus c square n dash minus p dash right, plus u dash square. We are multiplying with u dash square now. U dash square into a square n square plus b square n square plus c square n square minus p square is equal to 0. A square n square plus b square n square plus c square n square minus p square equal to 0. Is it this relation or not? This and this one and the same or not? Same result we got. A square into this total thing minus 2u dash u square into that 2u dash into this plus u dash square into this. This is your one of the important problem. Yes, next problem. This is also important problem. Previous examination question problem. This one. It is if 2r is the distance between. If 2r is the distance between is the distance between two parallel tangent planes. Two parallel tangent planes. Two parallel tangent planes to the ellipsoid. X square by a square plus y square by b square plus z square by c square is equal to 1. Prove that a line through origin. Prove that a line through origin. Line through origin. Prove that a line through origin perpendicular to the planes. Perpendicular to the planes lies on the cone. Lies on the cone. Here I am writing the cone equation of x square into a square minus r square plus y square into b square minus r square plus z square into c square minus r square is equal to 0. This is your question. If 2r is distance between two parallel tangent planes to this ellipsoid, no? Then you have to show that a line passing through origin and perpendicular to above parallel tangent planes should rise on this. That means our result should be this one. That's all. If you can use complete given data, your final result should be what? This one. X square into a square minus r square plus y square into b square minus r square plus z square into c square minus r square equal to 0. Right? My first work is, let us take your given conicoid. Define two parallel tangent planes to this conicoid. After that, let us find the distance between them and equate it to 2r. Because in the statement what they given, 2r is the distance between two parallel tangent planes. First of all, I want to do work up to there. Right? The equations of two parallel tangent planes. Two parallel tangent planes to given conicoid. What is that conicoid? X square by a square plus y square by b square plus z square by c square equal to 1 is, you know that Lx plus my plus nz is equal to plus or minus square root of a square m square plus b square m square plus c square m square, according to your theorem number 2. After theorem number 2, I explain more. If your conicoid is like this one, then b value should be this. Now Lx plus my plus nz equal to what? Then you have plus or minus should be there. I want to take both. I mean, here according to positive sign you get one tangent plane, according to negative sign you get other tangent plane. Both are what? Parallel tangent planes to this conicoid. Those results I am doing right now. I mean, this implies Lx plus my plus nz is equal to root of a square m square plus b square m square plus c square m square and Lx plus my plus nz is equal to minus root of a square m square plus b square m square plus c square m square are parallel tangent planes. Parallel tangent planes to given conicoid or given ellipsoid, whatever it may be, you can use both. Ellipsoid or conicoid, no problem. Right? In the next step, take this one to this side and this one to this side. I am writing proper plane form. Lx plus my plus nz minus root of a square l square plus b square m square plus c square m square is equal to 0 and other plane is what? Lx plus my plus nz plus square root of a square x square plus b square m square plus c square m square is equal to 0. But in the statement what they give, 2r is the distance between these two parallel tangent planes. I mean, distance between these two planes find out. If suppose your plane is Lx plus my plus nz, minus d1 equal to 0, lx plus my plus nz plus d2 equal to 0. Then distance between those two parallel planes should be what? Mod d2 minus d1 or d1 minus d2 by root of l square plus m square plus n square. That result is equal to 2r. That I am going to define. Otherwise, first define distance between these two tangent planes, parallel planes. Distance between parallel tangent planes. B modulus d1 d2 minus d1 means root of a square m square plus b square m square plus c square m square. Minus into minus becomes plus because here already d1 is minus d2 minus d1. It is what? Plus root of a square m square plus b square m square plus c square m square whole by square root of n square plus m square plus n square. Are you following or no? This is in the form of lx plus my plus nz minus d1 equal to 0, lx plus my plus nz plus d2 equal to 0. Perpendicular distance between them is what? Mod d2 minus d1 by square root of l square plus m square plus n square. In planes I define distance between or perpendicular distance between two parallel planes. That condition we use it here, right? I mean this we can write as directly. This is what? 2 times this numerator. Mod 2 or 2 you can take outside the modulus because it is constant into modulus root of a square l square plus b square m square plus c square m square whole by square root of m square plus m square plus m square. This is perpendicular distance between these two parallel planes. But in the statement what they given 2r is the distance between about two planes now. So that this should equal to what? 2r. That I am proceeding here. Given that 2r is the distance between above parallel planes. That implies so that 2 into modulus square root of a square l square plus b square m square plus c square n square whole by square root of n square plus m square plus n square should equal to what? 2r or not. I mean this is equal to 2r equals 2 gets cancelled, right? Next do cross multiplication and then remove root for that squaring condition. Squaring on both sides. We get directly this my writing. Squaring condition also use modulus gets cancelled, root gets cancelled. It is a square m square plus b square m square plus c square n square is equal to r square into n square plus m square plus n square. Just let us take square condition on both sides and take this denominator to other side. No, you get this, right? Now in the next step, no, let us take all the terms to one side. Write down separately l square coefficient, m square coefficient, n square coefficient. This is l square coefficient. Take this one to left side. It is what? A square minus r square into l square. A square minus r square into l square plus b square minus r square into m square. B square minus r square into m square plus c square minus r square into n square is equal to 0. Any doubt is there? Right? Let it be. This is some relation number 1. No, this is the first one. Okay. According to this relation, we did some work. We got some expression. Keep this result aside. But in the question, what they want to know? A line through origin perpendicular to these planes, these tangent planes should lies on this cone. That means in the next step, define a line which can passes through the origin and perpendicular to this plane. Perpendicular to these planes means what now? That line direction ratio should be L comma M comma N, because in this plane L comma M comma N are what now? Direction ratios of the normal to the plane. Normal means perpendicular line or not. Now this line direction ratios are L comma M comma N, and the origin is a point on the line. Now is it possible to define line equation or not? Just proceed that. Now we are going to form the equation of a line. The equation of a line passing through origin and perpendicular to above parallel planes. Above parallel planes is, what is that? X minus 0 by L, because 0 is the point, 0 0 0 origin, and perpendicular to parallel planes means L M N becomes what? Direction ratios of the line. X minus 0 by L is equal to Y minus 0 by M is equal to Z minus 0 by L. Any problem here? Otherwise you can write it as, one more step I am writing now. That last line you can write as what now? X by L is equal to Y by M is equal to Z by L. Let it be, this is number 2 better. Okay now? Now by using the equations 1 and 2, let us eliminate L, M, N. Because L, M, N are what now? Our taken notations nowhere in the straight line. We taken my L, M, N are direction ratios of the normal to the parallel tangent planes. At end stages we must eliminate them. For that, by using equations 1 and 2, let us eliminate L, M. You know how to eliminate them. In equation 1, substitute L equal to X, M equal to Y, N equal to Z. Like that you can eliminate L, M, N. Eliminating L comma M comma N using equations 1 and 2, we get, it's simple, I told you. Substitute L equal to X, M equal to Y, N equal to Z in this equation number 1. It is A square minus R square into X square, because L equal to X we are using, plus B square minus R square into Y square plus C square minus R square into Z square is equal to 0. Is it your required code or not? I mean, this line should lies on this code, right? This is about another important question. Next, let us see definition of enveloping cone of the conicoid. Enveloping cone of the conicoid. Enveloping cone of the conicoid, right? It is similar to your enveloping cone condition in unit number 2. Let us take a conicoid. For my convenience, I am taking it as ellipsoid. Any conicoid you can take. I want to take this surface S is what? Ellipsoid. Now take a point P which is outside to the ellipsoid or conicoid. I mean, this P is an exterior point of the conicoid. Now let us proceed. All tangent lines to this conicoid which passes through point P. This is a tangent line which passes through point P. This conicoid. This is a tangent line which passes through point P to this conicoid. This forms a new surface. That new surface is called as what? Enveloping cone of this conicoid. This is called as what? Enveloping cone of the conicoid. Following or not? Let P is an exterior point of the conicoid S. Then the set of all tangent lines to conicoid which passes through point P forms a cone which is called as enveloping cone of the conicoid. This is the definition of enveloping cone in the conicoid. Here this P is called as what now? Vertex of this cone. Here this P is called as what? Vertex of this cone. Right? This is about your enveloping cone definition. Now let us see here theorem. is similar to unit number 2. In course we proceed now, analytical theorem. That same theorem we are using here. No? Then we take a surface S. Here S is general surface. Here we are taking conicoid. That is the only difference. I mean in this chapter, theorem number 3. It is let P x1 y1 z1 is not a point on the conicoid, is not a point on the conicoid. That conicoid I am taking S now, which is what now? Ax square plus by square plus cz square minus 1 equal to 0. Then prove that the equation of enveloping cone of P, the equation of enveloping cone of point P with respect to the conicoid, S equal to 0, S means this one, S equal to 0 is same formula like your cones, S1 square equal to S into S11. You remember this, S1 square equal to S into S11. But what is S1 and S11, all those things I am writing here are, and they make you statement instead of S notation, but they make you like this. Let P x1 y1 z1 is not a point on the conicoid ax square plus by square plus cz square minus 1 equal to 0. Then prove that the equation of enveloping cone of P with respect to above conicoid is what now? S1 square. You know what is S1 now? It is ax x1 plus by y1 plus cz z1 minus 1 whole square is equal to S is this one, ax square plus by square plus cz square minus 1 into S11. It is what now? Ax1 square plus by1 square plus cz1 square minus 1. Same thing. Up here statement is over. S1 square means this one, S is this one, and S11 is this one. I mean in the statement instead of S they make directly cone equation, they give prove this result is your required answer. Right? This is your question mark, right? Yes, our work is first take your given conicoid. I said it is same like cones. In cones, this theorem we did not. Same work we are doing. There we taken S is sphere. Here we are taking conicoid. That is the only difference. There you taken sphere is what? X square plus y square plus z square minus a square equal to 0. Here we take S is what? Ax square plus by square plus z square minus 1 equal to 0. Apart from that, in the proof there is no difference at all. If you can practice that one, easily you can do this question. Right? Yes. First of all, I want to take given conicoid. Given conicoid is, if suppose they don't given S notation, what take here S. S is equal to ax square plus by square plus cz square minus 1 equal to 0. And P x1 y1 z1 is exterior point of the conicoid. It is exterior point of the conicoid, it's outside the conicoid. According to this point P, let us define S1, S11, all those things. You know what is S1? It is what? A into x1, Ax1 plus By1 plus Cz1 minus 1. And S11 also defined. It is what? Ax1 square, here replace x with x1, y with y1, z with z1. Ax1 square plus By1 square plus Cz1 square minus 1. Right? Now, in the next step, I want to define a line which can passes through point P and having some direction ratios L, M, A. equation of a line passing through point P. What is that now? X1, Y1, Z1, and having direction ratios L comma M comma L is, you know what is that line? X minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by M. To define a general point on this line, let us take this is equal to lambda and proceed with some relation number to 1. Now define a general point on above line. General point on above line is I am denoting that general point with A, right? That general point is this one. X is equal to x1 plus lambda L, y is equal to y1 plus lambda L, and z is equal to z1 plus lambda L, right? Now I want plot diagram for above diagram. This is suppose your ellipsoid, or you can take any conicoid. No, this is conicoid. No, this is your surface. Yes, no, and this is the point which is outside or exterior to this sphere, or conicoid. X1, Y1, Z1 point. No, right? Now let us go through lines like this one. Here looking like 2 lines only, but more than 2 lines also possible. This is 3-dimensional figure. That's why only 2 lines are looking properly. No, but whatever lines passing through point P and touches this conicoid forms a cone. That is your enveloping cone of this conicoid. Right? Up to here, what we did was we taken this conicoid S. That is this. Right. Keep aside. We taken this point P. Now we are defining this line equation. Equation of the line passing through point P and having some direction ratios L comma M comma L. That is this equation 1. Equation 1 is this line equation. This or this anything you can take. Right? After defining that, let us go through general point on that line. General point means basically anywhere on this line I want to fix at common staging, touching staging. Here take general point on capital A. Right? But whenever it is general point, no, is it on your given conicoid or not? I mean, in the next step, let us substitute this point A in your given conicoid. That what we are doing in the next step. Right? Let capital A is a point. Capital A is a point on the given conicoid. What is that conicoid? Ax square plus by square plus cz square minus 1 equal to 0. This implies A into x1 plus lambda L whole square plus b into y1 plus lambda L whole square plus c into z1 plus lambda L whole square minus 1 is equal to 0. Right? After getting this one, write down this one as a quadratic equation in terms of lambda. First I am going to write lambda square term. So proceed a plus b whole square. No? In that b square term gives what? Lambda square or not? It is a square plus b m square plus c m square into lambda square. This is lambda square coefficient. A square plus b m square plus c m square into lambda square plus lambda coefficient, right now. Lambda is nothing but what? Under this is 2ab term or not? In that 2 I want to take common, lambda I want to take common. Then it is what? A into x1l or lx1 or not? A l x1 plus b m y1 plus c n z1. Lambda a l x1 plus b m y1 plus c n z1 to outside, no, and lambda also you can take outside. Any doubt? Next proceed free from lambda. Now what is that? A x1 square plus by1 square plus cz1 square plus ax1 square plus by1 square plus cz1 square minus 1 is equal to 0, right? This is a quadratic equation in terms of lambda, but this line is what touching this or tangent line to this conicoid or not. Whenever it is a tangent line, no, roots of this equation are equal. Lambda values must be equal, means roots of this equation are equal. Hence its discriminant becomes 0. That I want to see, right? We know that. Line equation 1 touches given conicoid, so that roots of above equation are equal. Roots of above equation are equal. Hence its discriminant becomes 0. Its discriminant becomes 0. Discriminant means what? This is in the form of ax square plus by ax square plus ax square plus bx plus c equal to 0. Discriminant is what? B square minus 4ac equal to 0. Use that condition. B square means what? 4 into ALX1 plus BMY1 plus CNZ1 whole square, B square minus 4AC. A is this now? AL square plus BM square plus CN square into 4AC is this now? AX1 square plus by1 square plus cz1 square minus 1 is equal to 0. Clear reason I am writing, since b square minus 4ac equal to 0. Any problem is there? Here 4 you can cancel, right? And take this negative term to other side, and this direct I want to write s11. Here I want to use s11 to reduce this relation. I mean, this you can write as ALX1 plus BMY1 plus CNZ1 whole square is equal to AL square plus BM square plus CN square into, this is what now? S11 into S11. Any doubt is there? Let it be, this is number 2. Now by using equations 1 and 2, let us eliminate LMN, because LMN are our taken notations nowhere in the statement. We need to eliminate them. But how can we eliminate one? Substitute in this one. L equal to x minus x1, L equal to y minus y1, L equal to z minus z1. Like that you can eliminate. I am doing that work now. Eliminating L comma M comma N using equations 1 and 2, we get this. What is that elimination work first of all? Ax1 into L is this now? Ax1 into x minus x1. Any problem is there? Ax1 into L is what? X minus x1 plus by1 into y minus y1, by1 into y minus y1 plus cz1 into z minus z1 whole square is equal to a into L is what? X minus x1, a into x minus x1 whole square plus b into y minus y1 whole square plus c into z minus z1 whole square. A into x minus x1 whole square plus b into y minus y1 whole square, a into x minus x1 whole square plus b into y minus y1 whole square plus c into z minus z1 whole square plus c into z minus z1 whole square whole into s11. whole into S11. This S11 I written as it is. Any doubt is there? In the next step, just we have to do some mathematical work now. I want to remove these lines. Just simple mathematical work we have to do in the next step now. This I am writing as AXX1 plus BYY1 plus CZZ1 is one combination. This negative term is other combination. It is AXX1 plus BYY1 plus CZZ1. This is one combination in this closed bracket. Right? Minus of AX1 square plus BY1 square plus CZ1 square. Minus I am taking common. Minus of AX1 square plus BY1 square plus CZ1 square whole square. This is your left side portion. This left side portion. Right? Next go to right side now. In the right side now, let us go through this is A minus B whole square expansion now. There first write down A square term now. A square becomes what now here? AX square plus BY square plus CZ square plus CZ square, that is A square term. Next 2AB term, actually minus 2AB is there now. Minus 2 I want to take common. Minus 2 let us take common and write remaining term. 2AB now, I mean AXX1 now. AXX1 plus minus 2 taken outside, this is what? BYY1 plus CZZ1. Any problem with this? Next B square term proceed here. B square means what now? Is it AX1 square or not? Plus AX1 square plus BY1 square plus CZ1 square. This total simplification is over into S11. Any problem here? Again, here some small substitutions I want to do to get our proper form. Now here I want to subtract with 1. Here also I want to subtract with 1. Minus 1 into minus 1 is what? Plus 1 minus 1 gets cancelled. That is your left side adjustment. It is AXX1 plus BYY1 plus CZZ1 minus 1 minus of AX1 square plus BY1 square plus CZ1 square minus 1 whole square. Any problem is there? This minus 1, this plus 1 gets cancelled. At last you get this result only. In this also, here I want to proceed minus 1, here I want to proceed minus 1, here I want to proceed minus 1. Minus 1 becomes what? Minus 2. Minus into minus plus 2 becomes 0. Right? It is AX square plus BY square plus CZ square minus 1 minus 2 into AXX1 plus BYY1 plus CZZ1 minus 1 plus AX1 square plus BY1 square plus CZ1 square minus 1 whole into S11. Any problem with those adjustments? Okay, now in the beginning stages we take a notations for S11 and S1. Yes, S11 and S. Yes, S1, S11. All those notations used here. What is this one? Is it S11 or not? This implies, sorry, S1 or not this? S1 minus this is what? S11 whole square is equal to, this is what? S minus 2. This is what? S1 plus S11 whole into S1. Any problem? Just I use notation, starting notations. In the next step one, here expand according to A minus B whole square. A square is what? S1 square minus 2 S1 S11 plus S11 square is equal to, here take this S11 inside, S into S11 minus 2 S1 into S11 plus S11 square. Right? This S11 square, this S11 square gets cancelled. These two things also we can cancel. then what is the remaining result here? S1 square is equal to S into S11. Is it? That is your about that formula. This be equation of enveloping cone of the conicoid. This be equation of enveloping cone of the conicoid. This is about your theorem. Right?